So let's then talk about visualization. Now this is, I really hesitate a little bit because in order to make sense about the visualization, the basics are the graph, histogram and all that. And to an extent, I can start talking about it right away. But you'll see when I start to talk about statistics, literally statistics, probability statistics, a lot of that will be more the meaning of a lot of things about histogram, about cumulative, would make a lot more sense. But let's try. I think we can. So now this is just one line. This is very interesting. Statistics as numerical visualization. Imagine, you don't have iPhone, you have paper. Okay? Well, never mind. You don't have paper, you have telegram. You know telegram? In the Old West, sometimes you have Pony Express. You know what Pony Express is? You carry a message, of course, one from St. Louis to Kansas, then to Kansas to Pony Express. But anyway, you have very limited communication. Okay? And you travel hundreds of miles, and you want to set up a shirt business, right? You want to tell your parents at home, you know, please send me some shirts so I can sell. Actually, back then they wouldn't do that. Let's assume you say, okay, send me some shirts so I can sell. Yeah. But these people are not like in Kansas. Okay? Californians, they have different shapes. Can you imagine? Yeah. Can you visualize? Well, what's the best way to visualize California if you only have telegram? You can certainly say how tall they are. Yeah. You're selling a shirt, so hair color doesn't matter. How fat they are. Okay. Californians are not like us in the Midwest. They're taller, but they're skinny, or they have short legs. So try to imagine that. So statistics. Now I can't say, you know, I'm going to sell shirts to California. So all Californians are exactly 6 feet tall or 6 feet 2 inches. I can't say that, right? What do I say? On average, right? So concepts like statistical average, standard deviation, these were the most communicative, the most intuitive visualization tools of the last century, right? Think about it. You don't have a fact, so you can't draw a picture of California. And say, well, you can say the Pony Express, say telegraph. Right? You can only have a telegraph are very expensive. You get paid by you get charged by word. So what I will do is to say average height 6 feet 2 inches. Average waist 42. That is the technology, the state-of-the-art visualization tool, right? Because you know you're talking about the same thing, or average height. And at home, they can take home and say, okay, if the average length is like this, average width is like this, then the shirt should kind of look like that. Without sending a picture of a Californian, with someone in Kansas. Right? Okay? Well, you know, in California, they have, well, somewhere you have horses. You want to make clothes for horses. Dogs are very good example. Dogs are very different. Right? You can't imagine what an Alsatian looked like, but you can certainly keep the measurement. And you can keep the measurement on average. And you can keep a degree of variability by standard deviation. Right? Why does that matter? Because I'm making shirts for California, I need to know if I need to make one size, the t-shirt, one size fit all. Because most of them are the same size, so I have to make small, medium, large, Well, where would I make medium? Where would I make small? Where would I make large? Okay. All of this, you can science. You can put so much math and science into it. If I make the medium size shirt this dimension, what is the probability that I will cover 30% of the population? This is called statistical analysis. This comes, but you can think of it as visualization. You use numbers to visualize. But now, yeah. So you have to do a lot of mental gymnastics, switching back and forth between data as number, data as model data, all kind of stuff, right? You have to be able to do that. And one of the things that we're going to be doing now is the visualization. So let's do some visualization. Okay. I'll give you a little bit of sort of like a traditional approach. You have data, you do some kind of statistical, descriptive statistic to explore your data. Once you explore your data, you make a hypothesis. Once you make a hypothesis, you build a model. You use the data to run the model so that the parameters of the model are representative of data. You test against the test data. Once you're happy with all of this, you can apply to new samples. Okay, so that's the whole pipeline. I call it pipeline. But the beginning is visualization. Now, visualization serves many purposes, but it's one of the most critical skills. I call it skill. It's not a technology. It's also skill, because visualization can be, like I said, the beginning of the exploration, or sometimes it's an end itself. In other words, if I want to communicate that we're in a danger of global warming, right? The sea ice is low, the Antarctic ice shelf is at the risk, or the temperature has been increasing from man-made greenhouse effect. I want to communicate this. I can use visualization. So it's not a visualization so that data scientists can form a hypothesis, right? It's an end in itself, literally. Yeah. And a large part of this, the classical will be like statistic, histogram, and so forth. But the modern version, to give the idea that, yeah, you can tell a story, is called infographics. Now, infographic is a very bad word in my opinion. Well, not bad word, it's been abused. Because when you look up, say, YouTube channel, infographics, or you look infographic this, infographic that, a lot of times you're actually looking at cartoons. Okay? You're looking at cartoon animation, little puppet or something like that. That's all good. Okay? Animation is not infographic. An infographic would be something like this. I want to give you a narrative. I want to give you a story. I want you to get the picture. I want you to visualize. But I want you to visualize in a way that represents this quantitative information. So let's say I want to say something, and this I don't have a slide for, but I'm going to draw a picture. Let's say I want to say that the competitive strategy, the competitive landscape is not good. You're dominated by big business. Okay, you dominate big business. In other words, it's not like free enterprise where you have a lot of fintech. But you actually, this industry, say banking, is dominated by this big player. That's my story. I want you to visualize that. Okay? But I want you to visualize by analogy, right? So I can say that big business eats small business. So how do I do that? So I draw a picture like big fish eats little fish, right? Big fish eats little fish. So I have big fish eats little fish. Okay? Does that look scary? That looks very scary. But this would only be a cartoon. What would make it a decent infographic the information contained in this is, let's say, I use the size is proportional to market share. Then I can see that the big fish is roughly 11 times as big, as opposed to 2 times as big. I can literally do this for all the banks and financial industry, and I say there are 4 big fish at the top, and there are 4, 5, 6 smaller fish, medium-sized fish, and tiny fish. I can do this to represent market share. So this would be what I would call a proper use of infographics. Now, it doesn't have to be cartoon. In fact, the essence of this, what's more important? All I have to do is say big fish eat little fish. I don't have to go through the artistic journey of drawing fish. The most important thing is not the fish, it's the size. Right? It's the size. It's the size. So visualization driven by quantities is more important, it's more powerful. And to that, I would turn you to the first, what I told you to do in the last week, a few days ago, yesterday. Have you seen the video of Florence Nightingale? That's very good. So, that's lovely. Florence Nightingale is like my hero. You guys are, well, I'm a Buddhist, but maybe some of you are Catholic. And Catholic have this tradition, very interesting. They would assign a saint to whatever occupation. Like there'd be a saint for fishermen, saint for warriors, saint for cobbler, and so forth. Okay? Well, I would say that Florence Nightingale is like a saint of statistics, of data science, statistics, data science, because she did this. Now, remember, Florence Nightingale was what? I think part of Victorian or Edwardian England, right? Now, women in the West are not very highly regarded. Okay? In fact, I remember back at PSR said he read the history of the Western contact with the Yodia. Their impression was that Thai women very good in commerce and were running things in charge. Okay? Well, that wouldn't have happened for another 100, 200 years in the West. So women were nothing in the West. Okay? Florence Nightingale was a woman. Okay? And she went to the parliament to get, support or funding for health reform. She wasn't speaking very loud. She was a woman. And this was the most important weapon she had, was this little graph. This is very interesting. By the way, the graph is very clever for theory. Well, I don't know. I don't know if she meant to do this. I told you that the size can be proportional, right? Well, technically, this is not true. This is because she did do the pie chart. The pie chart is composition. So the proportion represents the area. Area represents the proportion. Pie chart, area represents the proportion. Because she wants to represent pie chart different time period. Pie chart in January, in February, in March, in April. What she does is she squeezes a single pie chart into a pie wedge of different months. Okay? Of different months. Now listen to this. This is very important. I don't know if she's being cheeky about this. But when she did this, the proportionality is assigned to the length. So, because it's the length, the area is length squared. So actually, she was trying to say that the blue, which is the outer region, is bigger than the red, which is the middle region. This is actually very clever. The proportionality is not this, it's square root of this. Okay? But the point was cut across, meaning that more soldiers die from poor health in the hospital than from bullets. Okay. Except, when we see this, it's square, the area is very big. So very effective. Okay? That's it. And that's what a woman in Edwardian or Victorian could do. If she didn't have this, I doubt, British gentlemen, men, would not listen to women back then. Okay? You guys are lucky you guys are born here. Okay? So we have more esteem, respect to women. Historically, for a long time, since the UTI at least. Historically. So, based on this, you're saying all the different times of death. Okay? All the different times of death. And this was from Florence Nightingale. Now let's fast forward a little bit to somebody else who champions the visualization, and let's go to this guy. This guy's named Sankey. Okay? Matthew Henry Sankey. Well, this guy was what? He was an engineer. Came a little bit after Florence Nightingale. But anyway, let me make it now. Okay, right. It just takes a little there. So this is it. Basically, anytime you have to flow, engineers are dealing with flow. Think of floods, think of rivers, think of electricity, think of quantities that have to be preserved. In other words, you have some kind of pipe, basically, right? And the width of the pipe is the amount. So this is the birth of, well, he uses, he didn't call it Sankey diagram. They just use this in this book. But people saw this graph as very good, very useful, so came Sankey graph. And I use that, well, that we use it in the consultancy project that we do together. Okay? So, for example, I want to say out of 100 clients that flow into the system, how much they end up buying this and buying that, and not buying this, buying that. Okay? So, it's one of the most powerful. In fact, I would imagine that, in Excel you have pie chart, you have column. You should have Sankey as part of your standard vocabulary. So that's this guy. Okay, so you have Sankey, and let's go to this guy, Hans Rosling. This is very interesting. You can look him up. But a website called Gapminder. So he does this kind of thing. This, again, is like charts. What we have in Excel, but fancier than Excel. Remember the idea of giving you the narrative, the picture? Well, in this case, it's actually giving you the picture that relates three things together. Normally, you can go in and out as you please, but next time, okay? I will organize the bubble, but this time I have to close it. Anybody to go. No problem. Okay. Right. Normally you have X and Y, right? This time you have X, Y, and Z, or Z. That is the number represented by the size of the bubble. So in this case, it's income, life expectancy, and I think size or number of population of different countries. And what's cool about this is because the computation is not, it's just basically graph. So what you can do is run something like this. It's very interesting. So this is an element of time. So even another thing, right? A statistic for that. So that's the population of various country, income, and life expectancy. And you can see the year. Can you see the year behind it? Yeah? Yeah. It's a big thing. 18, 1902, 1905, and so forth. Yeah. So this is something you can do, okay, easily in mathematics. But when he did this, it's quite interesting, very popular. So you can see all kind of evolution. So this is giving you the story. Again, this you can look at it two ways. Visualization, so you can form a hypothesis, create a model. Or visualization tells the story. That's it. That's what you want to do. You already have you've done the job. The job is not to develop a model further. The job is to actually communicate. So this could be something like carbon dioxide emission. Could be electronic waste generation. You can communicate all kinds of things from this. So this is graphic, infographic, and a bit of animation. Except the animation is not cartoon little, toy bear or something, but animation in time. This is a lot more powerful. Then I'll show you something which is amazing, and I can't even do this. This is very computationally expensive. This is called cartogram. Cartogram means you take a map and you distort the map, and you make the size of the country proportional to whatever variable you want to play with. Okay? And you can literally look at this. Okay? And I downloaded a few just in case it takes a long time. But look at this. This is very interesting. This is coronavirus. Yeah? Big country, that's what? That's China. Thailand here somewhere. I think that's Thailand. So China dominates the story. And this was what? This was in January. Okay? Now let's look at, say, March. Oops. What happens in March? European takes over. Right? You still see Thailand a little bit here. By the way, we are really good. So that's Thailand. Considering we were the first country outside of China. And now let's go to, I think, May is last month, June. Okay? So that's what happened when you have idiots running the country. What's the green? Anybody? Russia. Yeah, that's. So you have basically two idiots on the Western Hemisphere. One's Trump, one's Bolsonaro. Okay? So that's what happened when you have idiots in charge. So Brazil, of all places, poor thing. Okay? They're already having a tough time. Okay. So Africa is better. European has come down a bit. Indonesia, Australia, New Zealand, very good. Thailand, all the Asian countries. So unfortunately, this is computationally very expensive. Okay? So there's no animation. Would be nice to have that animation from January to this. There isn't. It's too expensive apparently. That's my guess. That's why they don't have it. Now, before we turn to our example, this is also a map. Okay? This is one of the most famous maps in the world because it's actually London Underground map. Because it's very intuitive for the youth. Because you can't do anything once you get on the train. You can only go from one station to the other. You can only plan your station that way. You can't do anything else. You know what London tubes really look like? This. That's a real line. Okay, that's a real line. But of course, as with everything, the big central area, gets expanded. So compare this with this. Okay? This is very clear. I can say, well, what's I went to Imperial College, right? That's South Kensington. So it's here. Okay, wherever I want to go, I say, okay, this is me. Actually, it's between here and here. See what this is. So I'm over here. Okay, I want to go to the city. I take this line. Okay, I want to go shopping, go to Piccadilly, and so forth. So same line. Okay, and all this is a background. I say this is zone 1. So inner part of London. So all this, by the way, you can look at this. This is Northern Line. One after the other, that's separated by a lot of distance, as you recall. So that's the Thames. Yeah, that's the Thames. Right. So now let's look at something we have here. So a lot of this is I would cover a little bit more. Again, this, if you have, I really encourage, even though, you know, I was contacted fairly late, so I didn't have the opportunity to discuss whether how I can make the college supply Mathematica or require this as part of the course. But really, it's worth your own money. Okay? You can do a lot more in your prototyping. Because after all, you're not concerned with heavy-duty industrial application, right? Which is where you definitely need to go to C or Python or something like that. But in a prototyping, I'll show you just how simple this is. This is a function that says Bernoulli distribution. Bernoulli distribution is basically a coin toss. Okay, a coin toss with a probability of head equal to 0.2. So 1 in 5. How many of them? 50. So I toss 50 consecutive times. Then I take the total. Now, I'm making this more complicated than necessary, but I want to show you the point. The sum of independent, identically distributed Bernoulli random variable is a binomial random variable. So 50 coin tosses becomes 1 point. Then I create a table of 1,000 points. Then I make a histogram. And in Mathematica, you can make things pretty by something like this. Like chart element function looks like a glass rectangle. So if I don't have this, it just looks flat, that's all. Just make it pretty. Okay? So, more interesting is pair histogram. You see that a lot. Right? Especially when you compare, usually male and female, because that's a binary classification. Okay? So this is when I highlight in my note in orange, that means I'm lifting from real example that's in the reference page. So this one I already run, I think. Let me show you this one. This one's nice. No, sorry, this one. Right. This one is convoluted, but what it does is it takes the data called patient medical data for novel coronavirus COVID-19, groups by sex, yeah, and then make a pair histogram. So that's it. Now, here is where you actually need the internet, because when before you guys came, I came a bit earlier than you, and I ran all this because you need the internet hooked up. But for data like this, it's not too big. Okay, so it looks at the data separate to male and female. I can group by something else as well. Okay, the example here is male and female, and this is the age distribution. So you can see the age distribution from young to old. Okay, for male and female. So that's like visualizing distribution. We can talk a bit more like this, but think of this as rooted in classical tools that you have. Histogram. Yeah. Histogram then will form the basis of probability distribution. We'll talk about it next Monday. Okay. So let's visualize location. Now this is very interesting. I'll show you. What I can do is like this. I say geolist plot. Okay. And control equal and say Thailand. Now, when I do this, it does its own Google search, as it were, search over the data, but not. Okay, so Thailand and enter. So it actually say, okay, is it Thailand you want? Yes, it is Thailand. sometimes there is see, that's it. So you can do this, and you can do all the countries. Now, all this data is in the resource object in mathematics, so you can go to province or something like that. Now let's do something interesting. So we got country of Thailand. Let's say I want to, let me do again. So basically, I want Chulalongkorn, right? I ran this just in case. So this is Chulalongkorn. Well, let's do this. Let's just get Suvarnabhumi Airport. Chula. Yeah, so it's looking. Chulalongkorn Mahavidyalaya,ใช่ไหม? Yes. And that's you. Oops, sorry. Oh, there. And that's you. Right? You can zoom in, you can zoom out, you can whatever. So this is, what's the difference between this and true map? One is quote unquote projected map. It's accurate to the projection. There was somebody, you were talking about map projection project? The map projection in your, yeah. Map projection is very interesting because basically the earth is round, you want to make it flat, how do you make it flat? But in a small area such as surrounding a city, it's very easy to make it flat. Okay, so it is flat. And so you can literally do this. So you say from here to here, how long is that? You can measure the distance from here. Okay, because the distance is flat. Now, this is not representative of BTS. So if you want to do the London Tube equivalent, you wouldn't care about the distance. And this is interesting, and this is a bit more involved. What it is it looks up country data from the United Nations. So countries listed in the United Nations. List the capital, entity value from the country. Let's get the capital city. From the capital city, let's get the position, meaning this is global position. And this is very interesting. This is an algorithm. Now, this is not just visualization. This is heavy-duty computational. This is called finding shortest tool. In that simple question, if you can do this in analytical form, you win a Nobel Prize. What not tomorrow? You have to check. Okay? If you can literally do this for ordinary number of cities in analytical form, okay? I will bow down to you for another 10 days. Okay? But no, you won't. Okay? But anyway, Mathematica has a built-in heuristic, meaning approximation. Okay? And that approximation is fairly okay to do. In fact, every time you do a Google map, it involves that kind of algorithm. Are you guaranteed 100% that if you take this point to that point, you're taking the shortest path? No, because it's a heuristic. Well, in Google Maps, if the location is close enough, you can explore all the feasible combinations. But the method for doing it is arbitrary. It's something like, it's finding the shortest path between cities. If there are 3 cities, it's trivial. 100 cities, maybe it takes computer a second. 1,000 cities, maybe 2 minutes. 10,000 cities, maybe 5 days. 100,000 takes the age of the universe. It's that like that. It's combinatorial explosion. But anyway, you can do projection. See? You can do this. Now, this is a little bit more realistic, but from this distance, I can say the distance here. So it's not, you can see that Russia gets twisted. So if you want to look at the other side of the Earth, I think maybe 270. Let's go to St. Louis. St. Louis is kind of opposite. Okay, United States. So you can visualize all this. This is interesting. I'm not going to rerun it. It might take some time. But it does say what's the deepest, most interior part of Thailand. This one, I don't know what this, I did this, geobubble shot theme. All right, I'm just mapping population. So what I do here is take the cities, right? Take the city, 20 largest city in Thailand by population, and I just projected it. So we kind of like in the central area. Connectivity, this is very interesting, and this is the London map that I talked about. And we'll talk a little bit more about graph. Now let's visualize event. So timelines is a very interesting event. Again, it's in orange, so that means I take this example from this website. So you can add, what you can do is like play with it, change the parameter. For example, original parameter is looking at composer from Romantic era. So this is timeline. Beethoven, Schubert, Liszt, Mozart. Oh, Mozart. Okay, Chopin, Mozart. Okay, so this is Romantic period, right? So that's 50. They take the cut off generally in 1750 because before that we have Mozart and whatnot. Okay, and so this is also timeline. This is visualizing timeline, right? So all these people, poet, painter, you know any of these guys? Okay. Author, okay, you can do this. Okay, this is the composer. Now, time series is a different. Time series is not timeline. Think of it this way: timeline, you kind of want to mark a point when something happened, and that event is given by the name. But now, time series we actually have values. So something like stock market and so forth. Now, this whole thing here, what I have is stock market value for Apple, for Google, for this and that, right? And then, so that's the database. Look at the time series from January 19 to last month, right? And then this is just an arbitrary. Let's say I'm investing 14% in Apple, 11% in this and that, and so forth. So that's an allocation. So an allocation problem means you buy how much of what, right? If I bought this proportion at the beginning here, this is my profit. Well, not profit values. So obviously this is kind of like the plunge after COVID come back up. So this is visualizing the time series, very important. Okay, you can do that with Thai stocks if you like. I've done that. Not that interesting. Okay, visualizing flow, talk about Sankey diagrams. Visualizing connection, graph. I'll talk a little bit more about that. Right. So you can see that the visualization can be very powerful. And again, it's normally thought of as from my perspective, it's data exploration. But you can see here, this is not just data exploration. This is it. This is data telling the story. Revered statistical chart in history. So diagram of causes of mortality in the army in peace from Crimean War. So Florence Nightingale, of course, is known for being what's called Lady of the Land. She's the nurse. She takes the lamp and go look at the wounded soldier at night. But that's her most important legacy. It's patron saint of nursing, as it were. But I can also say not only is she a patron saint of nursing, she's also a patron saint of data science. At that time, there's no machine learning. You literally make your conclusion from visualizing the data. And in fact, she already made she didn't do this to begin with. She collected data. So she does everything from data collection, analysis. This is just the final PowerPoint as you can follow. Okay, right now, let's talk about use cases. Yeah. In fact, I kind of thought I would use this as an example, but I might as well give you a head start. What can you think of a use case? So all these websites give you use cases. Optimal control. Okay, steering. In fact, cyber is like a popular word that teenagers throw at each other whenever they do TikTok. It's not. Cybernetics has a real meaning. It comes from a Greek word, like cybernetics or something like that. So cybernetics is an English word, came from the Greek word that means steerman. Steerman means steerage. Okay? Why is it a steerage problem? Well, in a car, if you want to turn right, you turn right. If you want to turn left, you turn left. Okay? You can do a little bit of drifting if you like, and that's sort of like this, a side effect, as it were. But in a ship, you don't turn right as you turn right. Okay, you turn your rudder. Then it turns. But it doesn't turn right away because it relies on the current. And if you imagine you don't have a little boat, I do sailing, so it's very direct. I do this, and the boat spins. Well, if I'm driving a tanker, big tanker, if I turn right, it turns right, it doesn't turn right away. So by the time it starts turning, and then, oh, okay, it turns about right, so I'm going to turn back. By the time I've already overturned. Okay, so if I want to turn right, I turn right. Before it turns right, I already turned left, or return the steering. So it's there's a delay mechanism here. It doesn't happen right away. Same thing with Bank of Thailand. Okay, you don't lower interest rate today, and GDP shuts up tomorrow. GDP shoots up in a quarter, maybe in 2 quarters. And in the meantime, you don't see any result. So you think, wait a minute, maybe it's not enough, let me lower more interest rate. It turns out maybe you overshoot and you create inflation in 6 months' time. It's very difficult. So steering an economy, cybernetics, same word. Optimal control, same word. Steering the temperature. Now, if you don't feel warm yet, you might say, let's lower the thermostat a little bit more. That might be too much, actually. You might overdo it, right? So it's very tricky. This is called dynamic control. Okay? So the optimality is refers to the algorithm. So the optimality is not all the way up, all the way down. Oh, it's nice. So I'll just use the word control. Now, so these are all the data use case. In fact, I want you to read this. I'm going to give you the links again. You can read them. But I'll discuss a little bit about the data use case in banking, because first of all, I can give you more insight. Okay, fraud detection. Well, fraud detection. I'll talk about something else first. Fraud detection. I'll come back in a few minutes. Okay, managing customer data. Well, this is not banking. This is everything. Okay, so once again, what's data? Data is measurement attributes pertaining to sample population. Now, SCB has maybe 4 million times, something like that, right? So it's a lot. Yeah, so do we have Spark data? Yes, we do have Spark system. Are you going to use that in your fintech startup? No, probably not. Okay, so managing customer data. Well, this is not really data science. If you just call it managing customer data, because it's actually just database, right? It becomes data science when you actually want to get insights. You're going to do customer profiling. What kind of people have the money to save? What kind of people have the need to borrow? And it's a tricky thing because you want people to need to borrow money, but they have to be not so desperate that once they get the money, they run away, right? So they have to need the money, but we have to be sure that in the future, they won't need the money anymore. And they'll be pretty wealthy, so they'll return the money, right? So do you want people who need them? So a lot of times people who are willing to borrow aren't able to borrow because of the bad credit. So you don't always get, so you have to do this kind of trade-off. Get a lot of insight. Now, this is very important, risk modeling. Now, risk modeling for investment bank, I'll talk maybe in detail when some of you do a project in that. If not, I'll just bring it up. But that's like the problem we showed earlier with the Google thing. Yeah, you want to model the trajectory of individual stock, but you also want to optimize the allocation. So that's investment management. But in banking, there's even something even simpler. It's default estimation. We talk about customer segmentation. Well, it's in here somewhere. Well, let's say default detection. Basically, estimate based on your current income, your this, that, and so forth, probability that you will default. So that's a binary as well. Okay? But binary with a gradation. In other words, I have an output that says 1, you are going to default. 0, you're not going to default. But the real output is a gradation. Maybe it's a score, 0.7, 0.5. Okay? And you can do certain things with it. For example, well, I don't know how many people I should approve, but out of this batch, I just rank them all from the best to the worst. And if I have the budget to originate loan for this much, well, let's just say the top 5. Okay, let's still leave a little bit of room. I'll go one more guy, 3 more guys. It's not like that. In theory, it's a bit like that. So basically, you take the top scoring. So credit scoring, default estimation, that's technically it's not data science because you already have the data. It's more the machine learning application. Okay. Now we'll talk a little bit. Oh yeah, I'm going to talk about machine learning in relation to data science. Remind me. But the fraud detection, this is very important. Again, all of this is combination of machine learning, proper data science. But the fraud detection gets a little bit more data-ish because big data is because the data you're searching over would be something like machine logs and stuff like that. Okay? And also transaction pattern, lots of transaction pattern. If I want to say, are you a good customer? Are you going to buy something? Am I going to be able to sell you insurance? Are you going to buy this investment fund? I can look at your profile, right? Profile. So your income, blah, 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 blah. But if I want to do fraud detection, that's not good enough. I have to look at transaction pattern. For example, money launderer. They know that for a large transaction, say above 50,000 baht, the figure gets reported to the Bank of Thailand. But you need to move a large volume of money. So they just report inflow of say 49,835, and next month or next day 48,932, something like that. There'll be something to detect. And you just can't look at the end of month balance. Okay, you have to actually go to the transaction level. Transaction to get the behavior. Now, we do this also for customer segmentation. Okay? What kind of bank customer are you? Are you one of those who come to bank a lot and withdraw a small amount, use it for transaction? Or are you one of those who just use the credit card and only come to the bank once a year, or when you need to do the mortgage or something like that? So we look at transaction. You understand what I mean by transaction data? These are events with description. Amount, reason, when, why, how, from which branch to what branch. But now this website will give you sort of like a winner story, the usual, how come Airbnb and Amazon and Facebook and so forth and network. So this you can read on your own, I think. Now the more interesting would be, for example, when you deal with this page I like better, because it covers not only like commerce but things like diagnostic, medical science. Once again, a lot of this would be survey of machine learning application, not data analytics. So what I want to do is I guess the last 10 minutes, have you guys on the group basis start talking to me. But before that, let me just go a little bit about maybe do a little bit of Venn diagram. Okay. So let's do a Venn diagram of data science, data analytics, machine learning, and the big data. Okay. So okay, let's say this is big data. And this is data analytics. Okay? Let's play a little game. Let's say the data is so huge, you need a Hadoop system. So that obviously, right? That's the big data, right? Let's say I want customer segmentation using cluster analysis. I'll talk about that a little bit later. Where's that fit? But technically, it's just data analytics, but I can do data cluster analysis on a huge amount of people, right? Okay. Also, we talk about data, a big data being in terms of variety as well. So if I do clustering like age, sex, occupation, that's just tabular data. In order to be here, perhaps it's not just tabular, it's not just big, but I can do clustering based on your GPS log, the location that you do your check-in on Facebook, right? So, in terms of age, sex, income, education, two people are identical, right? But one person just can't keep their hand off Facebook, checks it every time, always checks it at cake shop, right? And the other person always checks it at library. Okay, so obviously I like the library person better, but that's not the point. Okay, but definitely those are features that are distinguishable from data that you wouldn't otherwise find in tabular form. So, what about, let's throw in machine learning. Now, I'll spend a little bit of time talking about machine learning here because, well, it was in here and I kind of skipped, right? Machine learning. Okay, should be in here. Well, for those of you who like to read and take pictures, you do that. You have it. Certainly, machine, magnetic. It's a thing that you create. It has to do a job, actually. It has to do a job. Yeah, otherwise you would make it. It has to do a job. Now, the job presumably is useful, it's doing something. Okay? So we have to think about, well, I think I put down watermill because it's, well, you don't see watermill very much, but let's say, you know, let's say you're running some kind of, well, you know what a watermill is, right? No? Okay. In the old days, let's say you want to do sewing, right? You need to drive the sewing machine. But the sewing machine may be driven by your foot, right? Or you can do some industrial thing. Now, the birth of industrialization is when you get external source of power. Any kind of power, any kind of motion, you turn it into a machine. Now, the first original easiest thing is water mill, which means that you put a little wheel next to a little stream, and as water comes in, it spins the wheel. That's it. And once you have a rotation movement, you can turn it into anything you like. So if you have a little lobe, like a cam lobe of an engine, basically it's a oblong thing. When it turns, it can kick a little seesaw mechanism at the end of which there's like a hammer. And so if you let that go, it starts pounding. And the lobe turns again, hit this thing, seesaw up, drop it again, so it becomes a hammering machine. That hammering machine can be used to do what? To extract grain from rice, from barley, from wheat, from whatever. So that's what a machine does. Okay? Now think of learning. Well, learning has to be, what's the difference between learning and knowledge? Knowledge is like knowledge. Knowledge is like information. Okay? But the knowledge is in the library, it's in my head. Okay? It's only when it gets into your head that it becomes learning. So to me, the essence of learning is not the knowledge itself, it's the localization. Okay? In the computer, it would be something like if you're downloading an app, or if you're copying a Python code, that's like a learning. And it's cheating, but to me, it's like learning. Because what is the know-how that's in the GitHub? You copy that page, put it in your Jupyter notebook, and you run it. It becomes a local thing. So, quote unquote, in that sense, that's learning. You don't know what you're doing, it's just copying, but at least it's localized. So to me, the essence of learning is localizing knowledge. So, what's a machine learning? First of all, before you get to machine learning, you have to have a learning machine. So it's a machine that learns the instruction. Yeah? It doesn't learn from being programmed directly. For example, if I were to say, if the height is this much, the weight is this much, the size of the nose is like this, likes to wear a blue shirt, this guy is 10. This is my program. If the machine is learning, it would be something like, I give the measurement of all the people, 10 and non-10. I give the weight of the people, 10 and non-10, and I make a label for this, and this is not. And of course, there's some variation because sometimes 10 eats a lot, so he weighs a little bit more, a little bit less, but still 10, right? Sometimes it's identical. So you give this, and you let the machine learn. Now, in this case, the learning is the task. Okay, remember I told you the machine has to do something, has to do some task. The task is to learn. It's not doing anything useful. It's when I use it the second time that it performs as a machine in the second sense of doing something useful, like if that person is like this, identify him as 10, open the door. Otherwise, don't open the door. Okay? Same. If I were to say, whoever use this kind of computer, right? Walks in, untape or whatever, 9 o'clock to 7, 9 in the evening, at least 1 weekend a month. Sell him whatever, computer upgrades. That's programming. But if I have a lot of data, I say, you know, some guys with this computer brand, with that computer brand, buys a lot, and then gives a level to, okay, these are the kind of people who would buy, this kind of people who wouldn't. And the computer learns. Now, I'll tell you how it does later, because that's the machine learning part. In fact, that's about 3 lectures, 4 lectures. And then it comes up with a rule. Now, then it performs the task because I can give you a new person and ask, is this guy gonna buy? Should I sell him something? Should I sell him this or should I sell him that? That's performing the task once it's learned. So it's machine twice, so to speak. It's machine when it learns. But once it's learned, it uses the rule to do something useful. That then becomes a machine. So it's a machine learning. That's that sense, another sense. Now, next week, okay, well, so you can take a picture or whatever you like. So the science here has to do with how to get the patient or machine to learn. And there's a lot of, again, a lot of science, a lot of mathematics. For example, I want to learn the machine, I want the machine to learn the word algebra. You know, that King minus man plus woman equal to queen. Then somebody has to think of an algorithm of turning words into vectors, into numbers, right? I told you earlier, blue is equal to 75, green is equal to 102. That's just arbitrary, okay? But the computer here has an algorithm that learns to turn king into a vector of 300 long numbers, queen, man, woman, child, adult, all into numbers so that you can do algebra. This is not being told to do. It's not arbitrary. It's based on, you know, certain criteria like closeness or context. We'll talk about it. So this will be like a lecture near the end, I think, natural language processing. I have on my plate, on my menu, 1, e-commerce. Something like Lazada or selling stuff, or Uber, or this, that, app, this, that. Okay? That's an easy one. Yeah. Let's see that. Please, not all of you go for this. It'll be very boring. Second, something like, you know, using data science, data analytics to address maybe sustainability, ecology, environmental, social issue, something along that line, you know. So they're like data scientists saves the world. Okay, make quick money, saves the world. Then things like more heavy duty, maybe application of machine learning that has to do with visual recognition, diagnostic, medical science. You know, like look at X-ray, diagnostic, or does something with that kind of data. Some kind of medical imaging, maybe. Okay, or maybe not medical. Maybe face detection. Maybe Facebook. Maybe something with facial, visual. Okay. Some kind of text, working around text. But this area is kind of not really my thing. But if you're interested, certainly that kind of word algebra, is kind of natural language processing. Then you have things like graph, network, association, who is connected to who, like social network. Okay? In a way, that's more my thing because I was the one who introduced this concept to banking relationship, at least in the Bank of Thailand. Like instead of who's gossiping with whom, it's which bank or which financial companies is borrowing from which bank interbank money market. So this kind of relationship, who's connected to whom, connectivity, social network. Technically, it's called graph. Mathematically, it's called graph. You have nodes, little circle, and then arc, like the line that connects them. The line can be directed, like I talk to you or I know you, or the line can be bidirectional. Like distance is bidirectional. You don't have to know me and I have to know you. If I know you, I know you. Okay? But it's something like celebrity or social influencer, maybe it's one directional. Okay? And then you can think about project that has to do like visualization, heavy duty interactive visualization tools. A bit like this, geographical. Maybe you can do some kind of map of metropolitan area and does a big data search and find out which area is busy or not busy or use a lot of internet or this area is overbuilt with coffee shops. This one can use more coffee shops. That sort of thing. Geographical. So imaging, maybe medical, not medical, geographical, text-based. So I guess, or finally, things like financial problems. Obviously, financial problems, there's a whole bunch of them, and I can go very deep in that because basically that's my career. Optimize algorithmic trading, investment management, risk modeling, default prediction, that sort of thing, or customer segmentation. Okay? With telemedicine, you're not relying only on the. Okay, we mentioned earlier about medical imaging. That would be like diagnostic, right? That's like diagnostic. You can do diagnostic at a big hospital, big computer. So when you talk about telemedicine, there are two aspects. One, whatever you can do at a big hospital, can you do it at little hospital? By which I mean this. So if you have a high accurate model of, say, screening for COVID or whatever, then you can do it at a big hospital, and you do it at a small hospital with an app, that sort of thing. So that's sort of like teleporting hospital. Make big hospital available. There's also the concept of, well, it's not the capability of the diagnosis, but it's literally the communication. Better telephone. Because if you think about it, you can describe already the condition, but you know how doctors come and feel you, that sort of thing. When you go to a hospital and the doctor listens to your chest. Now, imagine that you don't want to do, you're not so ambitious that you're going to do diagnostic with the telephone. But how is it possible to, for example, for you to touch yourself and record the vibration, say with a I don't know, haptic sensor or something, okay, right? And communicate this information to the hospital. So it's more like communication type thing. Once you get to the hospital, they can do the analysis there, right? So there's so like miniaturizing the diagnosis or miniaturizing the healthcare delivery, and the other one is more like, you know, bringing, you know, even something like, you know, we can show the rat. I have a rat. Take picture of the rat, pre-screening set, that sort of thing. Look up the database. Okay, this kind of rat is from a bad mushroom or something like that. Very good. Yeah, think about it. Think about it. Excellent. Okay. Whereas facial, you have to think of what exactly. Now, there's a difference between facial recognition and object recognition. Okay, object recognition just say there's a face. Like your camera, when it does the focus, say there's a face over here, focus over here. Doesn't have to be anybody. But once you take a picture of that, you notice it does automatically sort out to your friends. That's facial recognition. That's like an identity. Okay? So think about it. Think about on those lines. Now, you have to play around. There are three tools. One obviously is the Python world. The other one much simpler is mathematics, more powerful. But also there's another world which is the world device, like camera, like Raspberry Pi, you know, things like that. Haptic devices, yeah, you know, haptic really touching shapes and sort of thing. Sensor or something. So think about it. Good. At least you guys start talking. I want you, I guess I'll give it as an example. You haven't got a team.
Sorry?
Have you got a team?
Yeah.
You have a team. Who hasn't got a team? Okay, from now on, everybody has a team. I'll assume that. Okay, I'll give an assignment based on team now. Start to register your team, come up with a nice name. Okay, unless you have no hope. Okay, so let's do that. Next week before I start with the topic, I'm going to do a roundup on the team thing. Okay, so if you're very good, you can take the initiative and say, this is what my group is going to do. Okay, so let's do that thing. Okay, and by then you can get this thing sorted out. Okay, bye-bye.